Okay, this is day 2 of masts assembly. I want to talk about some fine points here, then we're going to crank this thing all the way up. This is the top hole, which is for a 10-foot rod, and these are lateral supports for the rotor. The rotor is capable of 400 pounds. The antenna is 29. We got some safety margin there, but I wanted to have some lateral support here. I mounted the rotor on the side of the beam instead of at the top. That way I don't have to worry about having torque and a cage and all the rest of that. This way the rotor is mounted here, and it's got these two holes to align the pole so that there'll be almost no side torque on the rotor. Once again, these are crooked in reference to the mast. Just my way of doing things. I wanted them to be sloped so we don't get rain. This is the center section. This collar here locks down so it can't go in any further. I got a pulley underneath the bottom that is tied to the bottom mast. So the bottom mast doesn't move. It just goes elevation tilt-wise. But this cable here is secured to the bottom mast. When I start doing the elevation pulley, I'm going to pull the middle pole up. As the middle pole pulls up, it gets further away from the base. So as this moves up and gets further away from here, this mast also gets further away from here. So what will happen is this mast, being tied to the bottom, will elevate at the same rate as this one. So when this one raises 13 feet, this will also raise 13 feet. It's a very simple arrangement. Two pulleys opposite sides. This one elevates the middle pole, and this one elevates the inner pole. This is the rotor pole. Over here is my detent, which is not loaded yet, but this is going to lock the center two poles in position. Of course, we got the winch in the cage, and that's the elevation winch. So let us have at it. We're going to crank this thing over, then we'll crank it up. So here we go. I put a clevis at the bottom to allow the cable to always be pulling straight against the cable bracket. That way I don't have a lot of distortion trying to stress the cable. You're going to see the nylon block hit right here up against that pole and align the pole left to right. Now she's locked in, not going to go anywhere. And that's what it looks like. We got the area for the rotor and the supports. Right now, the bottom mast is 16 feet tall. The center section is 5 feet above the inner section. So 16 foot plus 1 foot on the inner section plus the center section 5 more. So that's 6 and 16, that's 22 feet right now. 22 feet tall. And that happens to be the same diameter as this monster sunflower here. All right, now we're going to switch over on the power source so I can elevate the whole thing, and then I'll get back and see what it looks like. I haven't checked out the polarity on these motors. I think this is correct to elevate it. And what will happen is I'll pull down this cable here, which will pull up the 3.5-inch beam, which parasitically pulls up the 3-inch beam. Let's see if I got it going the right direction. First videos here. There we go. It's going the right way. Okay, if you can look closer, you can see that the 3-inch pole, the collar is up above the 3.5-inch pole, and the 3.5-inch pole is up. So let me try to see if I can zoom in on this a little bit. It's going to get more shaky, but Here we go. Okay, well, what happened? It came down. It looks like one of the cables couldn't take the strain. We got 2,700 pound cable on the winch, and this 2,700 pound cable is the cable to pull the thing up with, and then the other cable is 900 pound stainless steel. So we'll have to figure this out. So what happens on preliminary testing. Enjoy.